Hello, good afternoon. My name is Cao Yuhuang. I am the PTA of Tricircle in Pike and Okata release. Tricircle is to provide networking automation across different Neutron servers. We provide a local plug-in and a central plug-in behind the Neutron. For local plug-in, we call this server as the local Neutron, and the central plug-in with the Neutron server as the central Neutron. The central Neutron and the local Neutron will coordinate with each other for the cross-neutron networking automation. In Pike release, we introduced some new features. The first important feature is the cross-neutron VXLAN network. We use a shadow agent and a shadow port to cheat the neutron. One shadow agent is one agent without real host. So the shadow port is binding to shadow agent, but without any real host to run this port. And during the cross-neutron VXLAN networking, we propose to enable the ARP proxy so that you can reduce the MAC learning between different Neutron servers. When a port is updated with host information in one local Neutron, and the local plug-in will call the central Neutron server API to update the port with the host trainer IP information. And the central Neutron plug-in will save the shadow agent and shadow agent information to the database in the central Neutron. We have one database for Tricircle purpose. And then the central plug-in will track a synchronous job to establish cross-neutron VXLAN network. Because many Neutron servers may be involved, so it may be last long duration. So we use a synchronous job to do this. And the X job will run in the background to create the shadow port in other local Neutron servers with the shadow agent vtype information. When the local Neutron receives the shadow port creation request, the local plug-in will create the shadow agent and the shadow port locally. And then the X job will update the shadow port status to up. Because when the port status becomes up, the local Neutron will start the L2 population. And the real core plug-in, which is called by the local Neutron plug-in, will start the L2 population. So the shadow agent vtype information in the shadow port will be populated to regarding host for same VXLAN network. So all the ports in the local Neutron can understand the remote vtype in local Neutron, store the shadow agent information. We support different cross-neutron VXLAN network. The first one is P2P, point-to-point. We can establish the VXLAN tunneling from one host in one local Neutron to another host to another local Neutron. So the shadow agent's VTAP information. The second one is to establish the VXLAN network slow L2 gateway. We can put one L2 gateway in one local neutron, and this L2 gateway will serve for all ports in this neutron. So the VTAP populated in another neutron server will use the L2 gateway's IP as the VTAP. So all the incoming traffic will be sent to the L2 gateway, and the line L2 gateway forward the traffic to local port. And the third method we support is no operation, no op. For no op, we assume that the SDN controller on the local neutron will communicate with each other through BGP or other protocol to establish the tunneling information. So for no op operation, Tricircle will do nothing except for the VX9 segment allocation and IP address allocation to avoid the confliction. Another feature is the cross-neutron layer D networking. For cross-neutron layer D networking, is similar to the L2 network. We create one bridge network between different routers in different neutrons. This bridge network uses the shadow agent and the shadow port to establish the tunneling between different neutrons. But in this case, the gateway port will be created with shadow port in other neutron servers. Another one is that this network is external network for the router. It's external network. Why we use external network? Because if DVR is supported in local neutron, then many hosts for the LSD termination. So we have to use external network because only one termination for the router for external network. Okay, before LSD networking, we have to understand the several concepts. One is local network. Local network means the network can only present in one neutron server. And the local router also only presented in one neutron server. To create a local object, you only need to specify one availability zone hint for example, region 1 or region 2 to create a network and a router object. And we also have a cross-neutron object. For example, for cross-neutron layer 2 network and non-local router. For non-local router and cross-neutron layer 2 network, you have to create such object with multiple availability zone hint to represent that this object will be spawned into multiple neutron servers. For example, for NetSD and R3, it's working in region 1 and region 2. Then you need to specify the availability hint region 1 and region 2. Okay, when we have such networking object, we can create complex network topology. For example, for this network topology, it's multiple LSD gateway. North-south traffic could be handling locally, and east-west traffic will be handled by the SD router. So we can create a local router for R1 and R2 because only north-south traffic is needed for this router, and create one non-local router for cross-neutron layer 3 networking. R3 will be divided into R3-1, R3-2, and the bridge network by Tricircle automatically. So when you use the command line to create this object, you need to specify the availability hint. And for this network, when you attach the net 1 and the net 2 to R3, you need to create one port and a line. The network is attached to this port for R3 router. All these functions supported by OpenStack command line. So after we create such a topology, the traffic is like this. North-south traffic from the instance to net 1, R1, and the external network, or instance 2 to net 2 to R2 and the external net 2. But for east-west traffic, the instance traffic will go to the net 1 and R3-1 and R3-1 line to R3-2. Inside the configuration is like this. Tricircle will do it automatically. We create one host router in net 2, and the destination is if it's net 1's CIDR line, the next hop is the port 3. Port 3 is the port for net 2 attached to R3 and the line. So all the traffic to net 1 will go through the net 2 to R3. And in R3-2, we will add a configuration extra router in R3. The destination is net 1's CIDR. The next hop is port 4. For port 4, it should be port 2. Here it's port 2. Sorry. The destination is port 2, so the traffic will from R3 to port 2. Yeah. So the east-west traffic will go through the bridge network. And with such kind of networking object, we can create many different network topology. For example, use cross-layer 2 network to bridge the instance in different neutron server, different OpenStack, or use a non-local router to connect different instance using layer 3 network. You can refer to the networking guide in Tricircle official documentation site. There are some pros and cons for this kind of layer 3 networking. The pros is only one hop for north-south traffic. It's the shortest path, but there is 2 hop for east and west traffic. 2 hop east-west traffic. And the cons is that because we use host router, so the host router is only updated after the DHCP option is updated. So it's up to the least time for DHCP, how long the topology could be updated. If the topology is not frequently updated, this model works very well. But if it's frequently updated and you want it to take into effect immediately, we want to introduce a new topology in Queens. So in Pike release we have added some feature like Python Tricircle client and smoke test, and also support allow adjust pair, which will be used for LC networking and flat network, especially to support external network as the flat network, and some object update, for example, network subnet port, and pagination support for resource routing and async job management. Also, WSGI support and VLAN track and service functioning. In Pike release, we also have done some experiments that using Tricircle to support sales v2, so that we can scale single OpenStack slow sales v2 and Tricircle. So in Queens, we focus and we need help in closed neutron load balance service support and closed neutron QoS support and Nova Cell v2 support. And we also mentioned that we want to enhance the layer 3 networking model. For scale single OpenStack with Nova Cells v2, we can deploy local neutron and central neutron like this. Central neutron work together with Nova Cell API, Nova API, and for each Nova cell or multiple cell, we can deploy one local neutron with the cell. And multiple local neutron could be coordinated by one central neutron. So Tricircle plus neutron can work together with Nova Cells v2. We need help to build such a topology to scale single OpenStack. And we also hope to enhance the layer 3 networking. We just mentioned the counts for the layer 3 networking is up to DHCP this time. So we want to introduce one bridge network for east network and north-south traffic. So there will be one more hop for north-south traffic. We add one bridge here, and okay. So the north-south traffic will go like this. The instance traffic from net 1 to SD1 and LAN to SD2, R12 and net 2 to instance 2 is the west traffic will go to from the bridge network. But for north-south traffic, will go from the bridge network first and the LAN to the north-south local router. The pros is the network topology could be working no matter when a new network or instance joined the topology. It always works. The cons is that there is 2 hops for the north-south traffic, 1 more hop for the north-south traffic. Yeah. So I hope that many people can join and play Tricircle. And we also need your help. You can learn and play by yourself. So this documentation. Thank you. Thank you.